everybody, and welcome to the Singularity Lab. We are back here after a 2-month hiatus, and I gotta say, I am freaking excited, but I'm sure you guys can tell that we've got an amazing show for you today. We've got Avi Loeb joining us, but before he does, I'd like to welcome our co-host for today, Luis Jimenez. Luis, how are you today?
What's shaking, Michael Mataluni? How you
doing? Fantastic. I'm good. Your energy seems like you're just ready. You're jacked up and ready to go, yeah?
Yeah, I just got done doing the show, so I'm going to another show. 4 hours a day. Rocking it. I love it.
Well, it's great to have you. It's great to see you. It's been far too long. It's been almost 6 days, so that's just way too much. We've also got the one and only Brooks Lopez. Brooks, how the heck are you?
Hey guys, good to see you. It's been too long.
Yes. Well, what's that, Lou?
I said, "What's up, Brooks?"
Yes. Indeed. All right, so we got a killer show for you guys today. Great to have you here. But first, before we get started, I want to do something we do here on the Singularity Lab and talk about our cognitive bias and logical fallacies. Today's cognitive bias is the pessimism bias. And the pessimism bias is your ability to overstate the likelihood of a negative outcome. Pessimism is often a defense mechanism against disappointment. Perhaps the worst aspect of pessimism is that even if something good happens, you'll probably feel like shit anyway. Rough stuff. Any pessimism bias in y'all's lives lately?
Ooh, that's my whole life.
Pessimism bias? Are you a pessimist?
Yeah, man. After being an actor for 20 years and hearing, "Oh, you got the good kids," you know, or you know, you got the part even, and then it gets taken away for whatever reason, or they change their mind, or they write out the part, or just something you can't. That's out of your control.
You know, so I would like to think of myself. Oh, sorry, go ahead.
No, I was gonna say it's like being an actor is like you got to take it of it almost like dating when you were single. You know, if you ask 100 girls out, one of them is bound to say yes. At least one, right?
It's a numbers game, baby.
Out of 100, right?
Kind of like sales.
But best case scenario, 3 to 4. You know, so it's kind of the same thing with acting. It's like if you could bat 300, you're doing pretty good. You know, if you could book 3 out of 10 jobs, I'd say you're doing all right. And
I'd say if you do 3 out of 10, you're probably doing great in acting, right?
No, it depends on what you're doing.
That's fair.
You know, like it depends on what you're doing, how much it's paying, you know, and yeah, it just depends, man. There's a lot of levels in acting, a lot of different, you know, you could sustain yourself doing it without nobody really even knowing who you are.
Right. Yeah.
Especially if you're like a commercial actor.
Right.
Like, but yeah, hearing the word no a lot is kind of part of my life. So, you know, it's like
you build
this wall of pessimism. Like, okay, I'm reading this part. I know this is not going to me because you can feel it sometimes when you submit.
Right.
You know,
at that point, though, are you still getting beat down by the nose, or are you just like it's water off the duck's back and you're used to it?
Water off the duck's back. Yeah.
Yeah, so I wonder if that you get so far into it, so deep into it, you don't even have the pessimism, not the bias anymore. It's just like a stark reality, you know.
Well, it's the secret is getting to a point where you don't care.
Right.
You don't care anymore about the conclusion. You just know what the mission is. So you just keep grinding out the mission.
You separate the expectation from the outcome. And I think that's very important. Somebody who's not a pessimist is somebody who's we've got in the house today. Welcome everyone. Nick of Steel says, "Oh man, I do love some Avi Loeb." Hi Arlene. It's great to have you all here today. It's great to be back with the Singularity Lab, and it's great to have this gentleman joining us. Avi Loeb is a theoretical physicist and astrophysicist. He's got 900 papers under his belt. He's created the Galileo Project. I'm excited also not only to get an update about the Galileo Project, but also to get his thoughts on the James Webb telescope. He just wrote a very interesting article for The Hill as well. Ladies and gentlemen, without further ado, Avi Loeb.
Hello.
Nice to be with you.
Yeah, it's amazing to have you as usual, Avi. Why don't you start us off and kind of give us a brief breakdown of your most recent article, which I thought was fantastic. You talked quite a bit about James Webb and the potential for NASA to build more telescopes like this in the future to peer into the universe and see if we could find life out there, maybe even cities. Share with us what you wrote.
Right. So about a decade ago, I visited Abu Dhabi. There is a campus of NYU there that was just established, and the tour guide bragged that you can see the city lights from the moon. And I was there with a colleague, and we were wondering how far away can you see a city like Tokyo with the Hubble Space Telescope. And we just went through the calculation. Within a day, we figured out that you can see it out to somewhere between 30 to 50 times the Earth-Sun separation. So out to the Kuiper Belt, so to speak. And if you have a spaceship with that much light as the city of Tokyo, it will be visible to the Hubble Space Telescope out to the Kuiper Belt. But of course, we don't expect such a bright source of light over there. And a more practical approach would be to say, suppose there is a planet like the Earth around another star, and the closest we have is Proxima Centauri, which is 4 light years away. And it's a star that is 600 times fainter than the sun. It's a dwarf star. And as a result, the habitable zone, the region where if you have a planet, it will have roughly the same surface temperature as the Earth, where you can have liquid water and life as we know it. That habitable zone is 20 times closer than the Earth is from the sun. And it so happens that there is a planet just there with just 30% more mass than the Earth. So it's rocky probably and similar to the Earth in many ways, but it's 20 times closer to that star. And because of that, it's tidally locked. So it shows the star always the same face, the same side, just like the moon shows us here on Earth the same side. We don't see the other side of the moon. The Chinese went there. Anyway, so the point is that there is a permanent day side on this planet, which is called Proxima b, and a permanent night side. And my daughters always say that if we ever go there, they want a house on the strip that separates the two sides where they can see the sunset forever. The sun never sets because the day side is permanent, the night side is permanent. And this planet moves every 11 days, moves around the star. So at any event, if there is a civilization there, they would like to put some photovoltaic cells on the day side and transfer electricity to illuminate the night side because it's permanently dark there, and also perhaps warm it up because it's probably very cold. And the question is, can we tell? And we did a calculation with an undergraduate student from Stanford University where we showed that the James Webb Space Telescope could tell if there is illumination on the night side at a level of about 10% of what the star illuminates on the day side. So it's quite substantial. I mean, for example, on Earth right now, cities illuminate the night side just by 1% of the sunlight. It's a very small fraction, 1 part in 10,000. But in principle, the James Webb Space Telescope can see even that if it's very narrowly focused on some very tight range of wavelengths, about 1,000 times narrower than white light. So at any event, the point is we can search for city lights on Proxima b, and that would be fun to put limits. And the reason I was intrigued to write this essay for The Hill is because just a couple of days ago, I had an interview with Terry Virts, Colonel Virts. He is a NASA astronaut, a former commander of the International Space Station. He spent 7 months in space, he told me, and he said the most memorable moments he had was were looking down at the Earth at city lights and realizing how they delineate the continents. You know, that's one thing you immediately see during nighttime, and moreover, you can learn about politics when you see the city lights and compare that to the boundaries of countries. You see one country being illuminated more than another, and you learn about politics. So I was just inspired by this, and I wrote to him an email afterwards saying that it will be the Wirtz legacy for us to think about mapping city lights on other planets, because we can learn about their continents. And if we have good enough telescopes, we can learn about their politics. And therefore, I think that after Webb, NASA should build a bigger telescope that would allow us to look for city lights on other planets.
And do you think, like, as the James Webb, the strength of the James Webb telescope currently? Now, you said you think that would be able to detect that sort of light at 4.5 light years away, or we would need a bigger telescope?
Well, it will not be able to detect our cities. If we were to put our cities over there, we are just illuminating at a level, at the night side, at a level of 1% of the day side. But if it were 10% of the day side, then the Webb telescope could, in principle, detect that. So it really depends on the level of illumination. We are rather primitive in that sense. We illuminate a very small fraction of the night side. But maybe in the future, humanity will get more advanced and will illuminate more of the night side. Most of the night side, at the 99.99%, is still dark for us.
Right.
Do you have an idea of how much energy it would take to light up the other side, the dark side, to 10%?
Oh, it's very simple. If you need to illuminate, let's say, if you want to illuminate 10% at the 10% level of the day side, you just need to cover 10% of the area of the day side with photovoltaic cells and transfer that amount of energy to the other side. I mean, of course, there is some efficiency involved, so you might need to cover more than that. But it's a major engineering project. You need a lot of, if you're using stellar energy, of course, you can use nuclear reactors, which is a completely different approach. But if you just want to do clean energy, like you need to cover the surface with photovoltaic cells. So the fraction of the illumination you want to achieve is the fraction of the area of the day side you want to cover, pretty much, because you're using that energy. I should say that the same day that I spoke, it was an inspiring conversation with Colonel Wirtz, and the same day I also came across another interesting idea that I can mention to you, that I wrote a scientific paper about it, and that paper was accepted for publication within a day and a half. That's the shortest time span between an idea and publication that I ever had. So I set my own record, a day and a half.
Is that because you have a 900 paper track record, Avi, or does that help at all?
Well, it's not so much that, but I've never had a paper that I thought about writing that was published or accepted for publication within a day and a half. That's really a record. So I'll tell you what the idea was. The sun emits light. Okay, we all know that. And according to Einstein's theory of relativity, energy is equivalent to mass, right? We know that, E equal mc squared, right? So that means the sun is losing mass as it radiates, right? The mass of the sun is going down as it emits radiation. And as a result, the orbit of the Earth around the sun expands slightly. Turns out that it expands by 4 inches as a result of this effect, 4 inches per decade.
Wow.
That's very small. But if you were to consider the same effect for the Milky Way galaxy, which has many suns in it, like it has 50 billion times the luminosity of the sun, it turns out that this, because of the radiation coming out of the Milky Way, the orbit of the sun around the center of the Milky Way is also expanding 1 billion times faster than the Earth is expanding away from the sun. So it's a bigger effect. And thought about this simple idea and realized that it was not mentioned in the scientific literature. So I decided to write up a short paper pointing this out, and that's what it was. So Tuesday was a very busy day for me because both of these things happened.
I'll bet. So we've got a lot of questions coming in for you about, people want an update on the Galileo project, but first I have a couple questions more on the James Webb. We've got Brent Hornick who asks, will James Webb actually be looking for things like lights on planets? It seems to me they are already spoken for by other pursuits. Can you give us an idea of what sort of focus the James Webb telescope has and what access scientists have to it?
Right. So I actually took part in the first advisory committee that designed the James Webb Space Telescope. That was 1995 or so. And the reason I was part of that is because it was a telescope designed to look at the first stars, the first galaxies. And I pretty much was among the first to explore this subject. It's sort of the scientific version of the story of Genesis, how the first light was produced. And we know that the universe started 13.8 billion years ago, and initially it was very hot and dense. It was actually denser than the sun. So stars like the sun could not have existed early on. And the question is, when did the first stars form, the first galaxies? And theoretically, we predict that it happened around 100 million years after the Big Bang. And we haven't gone that far with our telescope so far. And the James Webb Space Telescope was designed to look for that light from the first generation of stars. And it was designed to be sensitive in the infrared because the wavelength of the light emitted by the stars is being stretched by the expansion of the universe since then. And it's stretched into the infrared. So you want an infrared telescope that is very sensitive, big. And it was called the Next Generation Space Telescope back then. Perhaps that name would have been less controversial now because it's not associated with any person. It's the next generation. But at any event, that was the original motivation, to study the first galaxies. And that's why it was designed to be in the infrared, a large telescope, 6.5 meters. The original budget was $500 million, and it was inflated by a factor of 20.
Right.
Over the years. And
10 billion, right, is what it ended up being
around
costing?
10 billion. That's and by the way, although we think 10 billion is a lot of money, it was developed over decades. Just to remind you, the defense bill that was approved by President Biden a month ago is $768 billion in 1 year for the United States alone. So if we ever find the extraterrestrials or a piece of equipment that was produced outside of this Earth with the Galileo Project, I think the political system might decide at that point to say, well, we've been worrying about other nations until now, but now that you told us there is something else out there, sort of like kids playing in a kindergarten, in the playground, and then playing with, toys, trucks and so forth, and then a real truck passes on the street and they say, oh wow, there is a city out there. So if the politicians will decide, wow, this is a priority item, then we might get $1 trillion a year to science. And that's thousands of times more than these biggest projects like the James Webb Space Telescope. Even though it sounds like a lot of money, it's nothing compared to what we allocate to defending ourselves against other people. That at any event, just coming back to the other scientific motivation since it took decades for this telescope to come to fruition. In the meantime, we discovered planets around other stars, and the same telescope can be used to study those planets. First, the embryos, the rocks that just like Lego pieces come together to make the planets. They usually, those disks of what are called planetesimals, they emit in the infrared, and then we can study them. We can also study the atmospheres of planets as they pass in front of their host star, and the light from the star passes through the atmosphere. So we can, with spectroscopy, we can tell the composition. the fingerprints of various molecules in the atmosphere. And it will not be good enough to tell if there is life, probably, but we could still find the CO2 and other molecules that are of it, or water. So in that sense, these are the two major frontiers, I would say, that are anticipated. But what we've learned from the Hubble Space Telescope is that very often in science, you can't really predict the main discoveries. Just to give you an example, with the Hubble Space Telescope, at some point, the director of the Space Telescope Science Institute in Baltimore got some discretionary time, and he didn't know what to do with it. So he assembled a bunch of astronomers to come to his office for a day and advise him how to use that time, the observing time that he has at his disposal. And each astronomer argued for using it for a different purpose, for his or her own research agenda, and there was no consensus. So they were all tired after lunch, and then someone out of desperation said, why don't we just like using a new car that you can race on the highway just to enjoy it?
Take it
Why
for a
don't we
spin.
take this powerful telescope and just stare at a random direction in the sky that has nothing in it and drill as deep as we can into the universe, okay? And that led to the Hubble Deep Field. And it was sort of the most stupid thing you can think of in a way, because it's looking at some random direction and going very deep, but it ended up being one of the most important discoveries, because it's just like digging through an archaeological site. So this Hubble Deep Field was able to uncover the most distant galaxies. They appear to be red, and basically doing what the James Webb Space Telescope is expected to do. It went really far and told us about how stars started to form in the early universe.
Quick question about that. You said they appeared red, so that would indicate redshift, meaning they're moving towards us?
No.
Opposite,
redshift is
away.
when they move away.
Okay.
Because
blue shift is toward, okay, right.
Red light has longer wavelength than blue light.
Right. Got it. And the other question was, will you have access in any way? Is there any point at which Avi Loeb will have access to the James Webb Telescope?
Oh, yeah, definitely. I'm fundamentally a theorist. I'm a person of ideas. I was once taken by an observer at Caltech. He listened to my lecture where I said how fascinating it was for me to go to Australia, look at the sky in Tasmania where there are no city lights, and I could see some of the objects that I'm studying, like the Andromeda Galaxy, for example. And he said, okay, well, there is some potential here to convert Avi into an observer, meaning a person that goes to telescopes and collects data. So he took me to the Palomar Observatory, and I should say that I was quite disappointed, because there is a lot of wasted time where you don't have good weather, or you're just waiting for the conditions to be right for you to observe. And I'm not used to such an inefficiency. As a theorist, I can control my schedule. So I'm fundamentally a theoretical astrophysicist, but I collaborate with people that collect data, and I will definitely be closely connected to what JWST is finding or discovering. And it's a very exciting discovery machine that we've never had before. And of course, the other thing it can do is, if we ever find another object that came from outside the solar system, like Oumuamua, we can observe it with much higher fidelity. And the biggest advantage of JWST is that it will be at the Lagrange point, L2, which is about a million miles away from Earth. That means that it will observe the object from a different direction than the telescopes on Earth. The Hubble Space Telescope was much, much closer to us, but this one will be very far, and therefore it would be able to monitor the motion of the object in 3 dimensions, because we will have the data from Earth, we will have the data from JWST, and we'll know the trajectory of the object to extreme precision, unprecedented. And moreover, it will be able to study the object from a different angle. And all of this would be quite exciting if we find another Oumuamua.
Right, and which we most likely will. I mean, we've seen even right after Oumuamua, we saw another interstellar object come within what, months or weeks after Oumuamua? Is that right?
No, a couple of years. But
It was a couple of years.
A couple of years, but
Okay.
it was not discovered by the Pan-STARRS telescope in Hawaii. It was discovered by a Russian amateur astronomer who was looking actually close to the sun. Nobody looks close to the sun. No professional astronomer.
Give it to the Russians. Yes.
Now, you may ask, why was he looking close to the sun? I mean, I don't want to speculate, but that's one way to find satellites.
It's interesting because, oh, sorry, go ahead.
At any event, he discovered this object, which happened to be a comet, just like a regular comet, nothing unusual. So when I was asked about it, people said, well, the second object appears to be a comet. It appears to be natural, just like the comets we have seen. Doesn't it convince you that Oumuamua was also natural? To which I said, if you find a plastic bottle on the beach and after that you find a rock, it doesn't make the plastic bottle a rock.
Right, just because you found it on the beach.
It actually makes it more unusual. That I should say, I met my wife on the first. I was fascinated by her on the first date.
Real quick, Lou, I'll let you guys have one quick question regarding the Lagrange point and the James Webb telescope. So, correct me if I'm wrong here, but the James Webb telescope has a sun shield. So it's basically in a place where it's still, because it's and you can explain this further, but it's balanced by different gravitational pulls. So it's actually still, and it has a shield protecting its view from behind it so that it can see out into the universe. So does that mean that it's always looking in the same direction? And so, like, if we saw another Oumuamua, we couldn't just turn it to look at it, right? We're just trying to triangulate it. Is that accurate?
No, you can turn it. It's just that it cannot look close to in the direction of the sun. It always needs to look away from the sun. But there is a wide range of angles that you can direct it at. And keep in mind that as the Earth orbits the sun, the object, the telescope is looking away from the sun, and it scans a very wide portion of the sky as a result. It's just that at different times it's limited, okay? And it's limited in different directions at different times of the year as we move around the sun. And of course, because it operates in the infrared, it has to be very cold, and that's why you have the shield that reflects sunlight and doesn't allow it to hit the telescope. We cannot service it. That's one of the challenges engineering-wise. The Hubble Space Telescope had an issue with its optics, and it was served. And NASA put a contact lens on the Hubble Space Telescope such that the initial aberration was corrected. We cannot do the same thing with JWST. It has to work, and that's in part why it was a challenging engineering project. Took a long time and was very expensive.
Yeah, but amazing the fact, like when that last sail was unfolded, and now they're articulating all of the individual pieces of glass to actually form one complete mirror. It's just a marvel of human engineering. Lou, you had a question for Avi?
Yeah, I really just had one question. That was, do we have that live stream set up of that porch yet, or what? I want an all access pass to this porch, Avi.
The last time you were on the show, Avi, you said that a lot of amazing people and conversations happen on that porch. Do we have a live stream yet?
The most recent one you can find on YouTube. There was Jesse Michaels interviewed me, and he came all the way from California that night. So he just arrived, and he was freezing. I told him we'll hold it in the porch. I put some heaters, but he was freezing, so I gave him some gloves. And if you look at the interview, he's shaking with gloves. I did not have any gloves because every morning at 5 a.m. I jog, irrespective of whether it's a snowstorm, a rain, it's a rainy day or whatever. I like nature the way it is, the challenges that it brings. I'm not that sensitive, but if you look at that interview, you will see the difference between a California person and an cost person.
That's for sure. Well, I did have a question about hardware and how, because you said you were on the first committee in 1995, and then this thing didn't launch until 2022. So we're talking about what, 27 years.
Yes.
Is it difficult, especially once the process of building this hardware? If you're halfway through the build and then a new breakthrough comes out in either electronics or solar panels or battery systems, do you ever have to completely scrap the build because the technology is so good that just come out? And how often does that happen if it does?
Well, in any project, major project of this magnitude, there is a time when you have to lock the technology. You cannot change it anymore because you start to build it, and you can't just adjust to the. So in fact, with the Hubble Space Telescope, by the time it was launched, we already had much better technologies available. And the more the telescope is delayed, the bigger is the gap between the locked technologies and the ones that are state of the art at the time that it's launched. So it really is very dependent on the project as to when you lock any particular component. But I remember the composition of the mirrors was set 2 decades ago. I mean, the beryllium. And so for each item, it's just the time when they started manufacturing it that they locked it, and you couldn't change it. And of course,
is there anything you wish right now that you could put on the James Webb telescope? Because I mean, you said by the time the Hubble launched that it was already pretty much outdated. So I'm assuming the same thing is happening with James Webb. Is there any one thing that you wish you could be like, I wish we could change this one thing, and that would really set this thing off to a whole nother level?
Well, there are 2 aspects. One is the technology, and the second is the priorities in terms of what you want to observe. And by the time you launch it, the science advanced, and therefore you have new questions that you want to answer. So, for example, people now talk about trying to image planets, and for that you need to block the starlight because the star is close to a planet. And so people are talking about concepts of blocking the light from the star, but it's not part of the James Webb Space Telescope, and it could have helped it a lot in terms of imaging planets, for example. But that's the way science is done. I mean, of course, there are missions that have a much shorter incubation time, that the technology doesn't lag as much behind. I should say that, for example, the intelligence agency has access to technologies that are far more advanced than astronomers have. And the proof is that about a decade ago, the government donated a couple of telescopes to astronomers that became part of the Roman Grace telescope now that is being worked on. And I'm sure that for the intelligence agencies, this was just technology of the past decade, the decade before they donated it to astronomers. But for astronomers, that was a great gift, and we used it and established the telescope around it, this observatory, space observatory. So if we had access to the same funds, as I mentioned before, that the defense bill allocates, to rather, disappointing traits of human nature, which is to fight each other. That if we were to invest that in science, where we are trying to learn about the universe, about the world around us, we would be much farther ahead. And if you just think about it, we haven't even addressed as of yet the question of whether we are the smartest kid on the block. And to me, that is the most exciting question. And if you were to ask people, the public is extremely excited about it. If the Galileo, one way to promote this subject is if the Galileo Project finds something unusual, like a low-hanging fruit that was never picked up because nobody took this path, And if we find something like that, it will change everything. And then suddenly science will get much more money. So that's the way I think of this. And some people ask me, how would you convince all these conservative people that say extraordinary claims require extraordinary evidence? Well, in my mind, it's really simple. You just need a megapixel image of an object that doesn't look like a natural, like a bird or an atmospheric phenomena, and that doesn't look like it's human-made because it's doing things that we cannot do. And if you exclude, just like Sherlock Holmes said, if you exclude all possibilities, whatever remains must be the truth. So if you exclude anything to do with Earth, whatever remains must be the truth. And I think we can be pretty confident as a cave dweller is about finding a cell phone that is not a rock.
Right.
Avi, do you think that? Sorry, Michael. Go ahead.
Well, no, I was just going to say we're going to get to. We've got a lot of questions coming in. We got a lot of super chats. I'm going to get to those. I promise you. Brooks, go ahead and ask your question. Then I'm going to get to some of these other questions.
I was just going to ask Avi. With the like you mentioned, the budgetary constraints. Do you think that we'll see maybe some of the silos between the defense and intelligence industries and science diminish a little bit, and instead of just getting 20-year-old satellites as gifts, maybe a little bit more knowledge sharing and information sharing?
No, I don't think so, because if you see what happens in the context of UAP, I can actually give you another example, very specific to something I worked on. So with my student, about 4 years ago, we looked back at data on meteors. These are objects entering the atmosphere of the Earth. And there is a catalog that was based on government data, okay? And we were looking at that catalog and trying to look for objects that move much faster than you expect for objects that are part of the solar system. So they came from outside the solar. That was after Oumuamua was discovered. We said, let's check the meteor data and find if there is any meteor that came from outside the solar system. That would be interesting. We found an object actually that was discovered in 2015. And it was very clearly moving too fast to be bound to the sun. Okay, so we wrote a scientific paper saying, look, this catalog implies that there was this object before Oumuamua, actually, 2015, which came from outside the solar system. And then the reviewer of the paper said, I don't believe the government. This makes no sense to rely on government data because there are no error bars. And I said, there are no error bars because the equipment used to detect this object has such good precision that they don't want to reveal it, because otherwise, it's the same equipment is used for national security purposes to monitor things coming towards the United States. And that didn't convince the referee. So fortunately, I knew someone in Los Alamos that I said, could you give us an upper limit on how uncertain is the measurement? And even that took months. And then he came back to me and said, well, all we can tell you is that it's less than a certain upper limit. I wrote it in the paper. We submitted it with my student, Amir Siraj, back to the journal. And the reviewer said, that's not enough. I don't trust the government. Once again, it's not a published document that you're relying on. It's someone telling you that. So then I went back to that person, and that is still waiting to happen. So the government, for now it's 4 years or more, haven't released an error bar, or basically the uncertainty in the measurement that was made public. Just the uncertainty on one object in 2015, just that piece of information was never released. And to me, it illustrates the fact that if that is not released, just the uncertainty, they released already the data itself. And I would expect the government to have instruments that can tell the difference between an object falling on Boston or an object going to New York City. They must have that precision. So I would expect them to have very good data, but they don't want to give the error bars. And as a result, our paper was never published. So It's really a very strange situation. So that leads me, by extrapolation, to suspect that classified data will never be declassified. And you can see that in the context of UAP. And that leads me also to say, let's collect our own data with the Galileo Project, because the sky is not classified. We can build our telescope systems using off-the-shelf instruments, put them together, make copies of them, and distribute them in various locations, and try to find unusual objects, and that's it. I mean, rather than waiting for Godot, waiting for the government to release their data, let's just collect it ourselves. And that's what astronomers are doing all the time. They look at the sky, except they don't care about nearby objects. So they look at very far away objects. And the Galileo Project is designing a telescope system that would focus on nearby objects and also have software, artificial intelligence systems that can tell the difference between a drone, a bird, an airplane, or something else.
And you basically convinced Harvard to let you do this because you said, well, we're still looking up.
Yeah, I mean, that was, don't laugh, that was not trivial. I was worried about it because if it were, they asked me whether it's part of my day job. And this question is quite serious because if it's not part of my day job, I can only do it for a small fraction of my time. But I thought about it and came up with the point that throughout my career I was interpreting data that came from telescopes, and that's exactly what we are doing with the Galileo Project. So there is no limit on how close an object is to the telescope in astronomy. We are looking at meteors, we are looking at asteroids, comets, at the sun. So there is nothing in the definition of astronomy that says the object cannot be closer than a certain distance, especially if it came from far away. So what we are trying to find is whether UAP came from far away, basically, fundamentally.
I would hate to be a bureaucrat trying to stand in your way, Avi. That would not be a fun job.
Well, I should tell you that if someone asks me what do I imagine hell being, it's full of committees.
You and me both, Avi.
Let me get to a couple of these real quick. The Meat Cutter says, truly great to see Mike back. Avi, thank you so much for making yourself available for interviews like this. I'll have to watch when I get home. Join the Discord, folks. It's fun. All right, we've got a lot of people who have questions about the update. They're looking for updates from the Galileo Project, but I just want to get a couple more of these in. Dr. Loeb, any thoughts? Thank you so much, Campbell. Dr. Loeb, any thoughts about the peer-reviewed measurements showing accelerated expansion in the Crab Nebula and filamentary structures similar to large-scale universe structure due to plasma scaling universal implications?
Right. So the Crab Nebula is basically the remnant from an exploding star, a star that exploded. When a star explodes, it creates a bubble around it. And that's what the Crab Nebula is. And usually the star leaves behind a neutron star, roughly the size of Boston, with a mass comparable to that of the sun. So just think about it, an object as compact as a city with a mass as big as the sun.
Wow.
That's called the neutron star. And these are just like, if they have magnetic field, they are like lighthouses. They can spin around and you see them as pulsars, these neutron stars. And by the way, if you ever ask yourself, what is making the gold that you have on a wedding band? The answer is collision of neutron stars. We just found it over the past few years because the LIGO experiment that is sensitive to gravitational waves identified a collision of two neutron stars through the gravitational wave signal, and we saw also the flare, the light emitted from that event, and the interpretation was that it's two neutron stars that collided that produced those heavy elements. They're called R-processed elements, among which is gold. So the sources of all evil on Earth, gold and uranium, are produced in these neutron star collisions. And you have to make the neutron stars in the first place, and you make them in these supernova explosions. So the point is, the Crab Nebula is that kind of a beast, and it's a bubble created by an exploding star. And then, of course, it has, the gas into which the explosion occurs has magnetic fields in it. Also, the explosion may send out bullets, very dense pieces of material that perhaps create some of these streaks. There is evidence for that in X-rays. But some of these filaments are a result of the magnetic fields, a result of the flow of gas. So it's quite a fascinating view to look at the Crab Nebula. It's quite amazing, a spectacular view. And we actually owe our existence to those supernova explosions, because that's how the heavy elements that are cooked in the interiors of stars are spewed out into the surrounding medium. So we are made of heavy elements. We are made of water that has oxygen. We are made of organic material that has carbon in it. And these elements were not produced in the Big Bang. They were produced in stars like the sun, in the core. But if all stars were like the sun, so when they die, the sun will basically, the envelope of the sun will expand, but the core of the sun that has all the heavy elements will simply cool off and shrink to what is called the white dwarf. So these heavy elements would never enrich the surrounding medium. So the only way to enrich the gas in between stars with heavy elements is through an explosion. And that happens in these supernovae. So the reason that we have carbon and oxygen is because there was a supernova nearby that expelled the guts of a star. And we are made of that gut, from the relics of those exploding stars. And so that's quite. And the first stars, before the first stars, there were no heavy elements. Life was not possible. An interesting question is, when did life start in the universe? We think that Albert Einstein was the smartest scientist that ever lived. But I bet you that he was not the smartest scientist since the Big Bang, 13.8 billion years ago. Most of the stars formed billions of years before the sun. So there must have been a scientist smarter than Albert Einstein on another planet around another star 1 billion years ago. And if there was such a scientist, perhaps that advanced scientific technological civilization produced probes that we can find around us. So that's the rationale behind the Galileo Project, to search. It's not a philosophical question. We should just look around. We shouldn't sit at home and say we don't have neighbors. That will not get rid of our neighbors. We should just look through the windows and check.
For a man who is all about science and is not that interested in poetry, that was quite beautiful, sir.
Great.
We've got another one here for you from John Brusso, who asks, will Luvoir A or B be built? How long should it take to build now with our JWST experience?
Right. So this question was addressed in the decadal survey of the astronomy community. So every 10 years, there is a committee that includes astronomers that decides about priorities for the next decade. And I actually chaired the board on physics and astronomy of the National Academies that appoints these committees. So I appointed the committee that operated in the last couple of years to define the priorities for the next decade in astronomy. And it came out with a report about a few months ago. And it talked about Luvoir. That's a telescope that will operate, be sensitive to the ultraviolet, to optical and infrared light, and be much bigger than the James Webb Space Telescope. And they talked about other big telescopes, but the forecast that they gave is a couple of decades from now, not in the immediate future.
Great. All right. So you've done a solid justice by segueing a bit into the Galileo Project, and I know so many folks are here to hear you talk more about it and the progress that is being made. Can you give us an idea of where we stand now? I always feel bad asking you this question because I'm like, I know how long science takes, but like we are very impatient people. So give us an idea where we're at.
Right. So we pretty much placed the orders for all the instruments we need for the first telescope system, and it should arrive by the end of March, hopefully. It just takes time for the vendors to ship us the components, and then in April we hope to put together those components on the roof of the Harvard College Observatory. That will be the first telescope system. So we have already the space on the roof of the Harvard College Observatory. We'll put it together. We have an engineer that will come on campus to put it together, and we'll start collecting data. Now, Boston is not the best site to collect data, but the idea is to check that the telescope system works. And what we will do is take a video of the sky, continuous video of the sky in the infrared. So we have a set of many infrared telescopes that basically monitor the entire sky at all times. And the advantage of the infrared is we can operate at night, and we don't need sunlight. It's sufficient to have warm objects for us to see them. And then during the day, of course, we will look at the reflected sunlight with an optical telescope that will also cover the entire sky with a fisheye camera. And so the idea is that we do not focus on a small region of the sky. We cover the entire sky. And then if there is an object of interest, we track it. And then we use our AI software to figure out the nature of this object. And for that, we are developing the relevant tools software-wise. And that will all work together. And there will be also a radio sensor that we will try to detect any radio waves from the object or reflected by the object. And then audio. We will have a very broad range of frequencies of sound waves to which we will be sensitive. So all of this is state-of-the-art equipment that we have now that was not available decades ago, and also the computers that we are using were not available. So it's all new territory in terms of the instrumentation, and you can't compare it to what, for example, the military personnel had on the Nimitz 2 decades ago. So we will get much higher quality data than was reported so far. And once the first telescope system works, hopefully by the summer of 2022, we will start making copies of it and starting to put them in more interesting locations. Boston is not very interesting. I should say that. It is very interesting, but for different purposes.
Right.
Well, just out of curiosity, for future investors out there, what are the costs so far to build this system on the roof?
This system would cost about $250K. So with the $2 million that I currently have, we'll build maybe 5 to 10 systems. But what we really need is hundreds of millions. And there are some very wealthy people that I hope will decide to fund us once they see that we are doing our job as promised. And so I'm always optimistic. I think that this is an extremely exciting subject that we are potentially able to find some low-hanging fruit. And when people said the extraordinary claims require extraordinary evidence, my answer is extraordinary evidence requires extraordinary funding. And by the way, $100 million is not a lot if you think about scientific projects. So, right. And besides, we also have a separate branch of the Galileo Project I wanted to mention. That's trying to get a high-resolution image of an object like Oumuamua that is very far from Earth. That requires a space mission, and we are currently in the process of designing that space mission. And that would cost more like $500 million. So that's a separate track of the Galileo Project. And I should say that in recent weeks, after our last conversation, the other development that was quite interesting is that we will have access to satellite data that was collected by Planet Labs. And that means that we could potentially look at the unidentified aerial phenomena from above. I should say that if we look at it from above, it need not be aerial. It could be above the atmosphere. So this way, you don't need to worry about birds or airplanes, or if you go high enough, above 50 kilometers, the only thing that is out there is space trash, like fragments from or satellites of our own making, And so it should be called the UP rather than UAP if it's above the atmosphere, because there is no air out there. For example, Oumuamua was pretty much in vacuum, and so I would rather change the nomenclature to UP, unidentified phenomena.
Oh boy, this nomenclature has gone through so many changes, and there's so many acronyms already.
So if you go to the zoo and you see when you see a giraffe, do you care how you call the giraffe? That's why, like I didn't pay much attention to the renaming of Pluto as not being a planet, because who cares? I mean, I don't care what you call an object as long as it's the same object. Shakespeare already said that about Rose.
By any other name.
So, by the way, speaking about Pluto, I'm really embarrassed by what we did about Pluto, because aside from trying to rename it, we sent this mission New Horizons to it, and there was a box that carried 30 grams of the ashes of the scientist who discovered Pluto, Clyde Tombaugh. And those ashes were no different than the ashes of a cigarette, the burned up DNA of this guy. And if an extraterrestrial finds this box, they would say, what is this primitive ritual that humans have of destroying the information about the person they want to commemorate? And what I want to do is send a spacecraft that will overtake that and apologize for this box.
So should we send the DNA instead rather than the ashes?
Yeah, so I actually asked the principal investigator of New Horizons, who is a Galileo team member, Alan Stern, why didn't they put the stem cell of Clyde Tombaugh or something? He said that would have been a bureaucratic nightmare at NASA. But instead, an alternative could be just the electronic record of Tombaugh's DNA. That would have been a good compromise, I think. And at least it would not embarrass us. I mean, of course, we send also the golden record on Voyager, and that's music of the Beatles. And, that's from the 60s. We have much better music now.
Wow. I'm shocked. That's coming from you. I feel like the Beatles.
Avi's in my camp. I like it.
Closer to your generation, man. That's you're saying.
No. I always like the latest music.
Huh.
Wow, interesting. Well, okay. So, what are you listening to now? Latest music, man.
Well, Dua Lipa.
Oh, okay.
And there are a number of. Billie Eilish. I like her as well quite a lot.
I just started listening to Greta Van Fleet. Have you guys heard Greta Van Fleet yet? Oh my gosh, it's like a modern day Zeppelin. Fucking phenomenal. Real quick, we got a question. John Music, speaking of music, says, what do you think about recent Navy officer admissions that over 10,000 USOs per day just in U.S. waters, many more per day globally, especially around Catalina and Guadalupe Island? Are you familiar with this area?
Yes, of course. That's where the limits, the reports came from military personnel. And yeah, that's very intriguing, I must say. But the problem with the data that was released, perhaps there is higher quality data that is not being released, that is classified. But it's intriguing, but it's not entirely convincing, because you can't write a scientific paper saying, look, there is definitely something there that we cannot explain. And that's the problem with all the existing data. If the government has much higher quality data, it's not out. We cannot really look at it. And frankly, my guess is if they have that, they probably don't know what it means. And, that was pretty much the spirit of the report that came from the Director of National Intelligence to Congress. We don't know what they are. It's unexplained. That's why scientists should look into that. That's what Bill Nelson said. And that's what I think should be done. But not everyone agrees. Yeah.
What do you think about other independent projects, for example, like UAPX, collecting this kind of data?
Well, the beauty of science is, as long as you do a good job, it doesn't matter who does it. So I can only wish them success, but I haven't seen yet the data they are collecting and the quality of it and whether it's trustworthy and what they are making of it. You see, that's so.
Would a scientific paper make their work? How would they be able to do that?
Yeah, a scientific paper that lays out the details of how the data was collected, and if they release at the same time also the data itself, then I'll be glad to analyze it and tell you what my opinion is. Because, if you see a flock of birds, you can argue that that's a wormhole. And I would say it's a flock of birds. So it really depends on the quality of the data.
Right. So they would need to bring you, and I guess that leads into another question. If somebody was able to bring you data that was that you felt was leading down a good path because it was quality data, can the Galileo Project then invest in those organizations to?
Yeah. Well, not invest in collecting high quality data. Some of the people involved in these organizations are members, affiliates of the Galileo Project. And the reason I brought them in is because I don't care about who gets the credit or anything. And I really want to figure out the answer. And by having a big tent and including people with different opinions, I can pretty much guarantee that we will be guided by the evidence, because I'm hearing everyone voice their opinion, and then we will collect our high quality data, and hopefully by the time we have high quality data, everyone will agree on what it means. And to me, that would mean that we are not missing anything, because you have people with different initial opinions that agree, converge. And that's the beauty of doing science. Unlike politics, in politics, you get this polarization. In science, there is a route, a path towards convergence, which is basically collecting data. And by the way, what you see in science because of that is some communities of scientists are reluctant to collect data because they think they know the answer in advance, or they've worked on a path that they don't want to be falsified.
That's what I was going to say.
Yeah.
Option
sure.
B is generally what I would think, because they would rather avoid the collection of data in order to ensure that they're not falsified. That's
yes, that you've seen already with the with the philosophers during the days of Galileo. They didn't want to look through his telescope. They put him in house arrest so that others would not listen. But if you were to ask those philosophers to design a rocket that will reach Mars, they will never get to that destination because they thought that Mars moves around the Earth. Okay, that was their worldview. So my point is, there is a way to tell if people are wrong. It's not a matter of who gets the most number of likes on Twitter. It's a question of getting the evidence that eventually nobody remembers those philosophers today. Today they would have tried to cancel Galileo on social media, but who cares? It's not it's not a popularity contest. It's a question of figuring out the reality that we live in. That's why I have a big problem with the idea of the metaverse, because people put goggles on their head and go to virtual realities that flatter their ego, that give them pleasure. Okay, it's just like taking recreational drugs, or believing in some truth of a cult. That, I mean, you can do whatever you want, that's fine, but it is not necessarily the reality that we all share.
right.
And for me, science fiction, some of the science fiction is like that because it doesn't abide by the laws of physics. Okay, so for example, in a forum that I attended in Washington in November, Jeff Bezos was saying that he was inspired to fund the space tourism by watching Star Trek as a kid. And I said to Avril Haines, the director of national intelligence, sitting next to me, I said, I never liked Star Trek because the storyline violated the laws of physics. And she said, we have to work on you, Avi. But, I wrote up an essay mentioning this in The Hill, okay, just a couple of weeks ago. And then the same day when it appeared, I get an email that William Shatner wants to speak with me. He played Captain Kirk in USS Enterprise in Star Trek. So
yes, we all like Star Trek here, Avi.
Okay. But so I went to that interview, and I said to him, I said, look, you probably will understand my point of view. I said, because you played Captain Kirk on some fictitious storyline that is a virtual reality. It doesn't really, you cannot send people to long journeys between stars. It makes no sense whatsoever based on the physics we know. So I said, but nevertheless, half a year ago, you flew into space, right? I mean, he flew on Jeff Bezos' craft, right? So I said, it was probably obvious to you the difference between the actual reality, being in space in the actual reality, and being in space in the virtual reality. And he completely agreed with me.
I read your
You
article.
see, now this makes me wonder, what is Avi Loeb's favorite science fiction movie?
Or does he have one?
Oh yeah, I do. It's called
Okay.
Arrival.
Arrival.
Oh,
Nice.
yes.
And
Okay.
Yes.
you know, about
good
a
one.
year ago, the director of Arrival, the producer of Arrival, contacted me and said that he enjoyed very much my book Extraterrestrial. And I said, I loved your work long before you knew about mine. I like this film because it addresses a very fundamental question about communication.
Yes.
Yeah.
That was one of the things that I just adored about Arrival was and I think that's one of the big things, right? Because you look at Star Trek and every single intelligent creature is humanoid, right? Which makes obviously no sense at all. But you know, you're at it's 1964, you're on a budget.
Yeah. No, I mean, it makes sense to have AI systems, you know, with robots. But the thing I wanted to say is what Arrival brings forward is this question of how to respond. You know, if you have an object, let's say the Galileo Project finds an object, okay, that clearly is not from this Earth, and it shows some intelligence. You know, it's collecting information and responding to the way we behave. And what do you do about it? Now, the protocols that were designed by SETI people for decades involve detecting a radio signal, and the nearest star is 4 light years away, so it takes 80 years for a round trip conversation. So and the stars at the edge of the Milky Way galaxy would take tens of thousands of years for us to communicate with. So there is no urgency when you deal with radio waves. But if something is in your backyard, you really have to respond immediately. And the question is, who represents Earth? Human, you know? And the second question is what to do, how to engage with it. And that's a serious matter because you don't have much time, right? You have to decide. And I'm just worried that even if we establish an organization that will deal with that, there will always be a guy somewhere that will say, the hell with it, I will engage.
Yeah.
Wow. Yeah. No, I mean, I think that movie also is about not only communication, trying to figure out communication with another entity, but trying to figure out communications just within our own planet. Because the thing that figures out or solves the problem is the eventuality that humans are going to have to be forced to really communicate, cooperate with each other as a planetary species.
Yeah, that's a huge challenge.
Before it could go out and start colonizing other places, we gotta kind of take care of our own backyard first.
Yeah, that's a huge challenge because, as I said before, we waste $1 trillion a year on things that, you know, that nothing good comes out of it. You know, and if you look at human history, it's full of situations where a group of people tries to feel superior relative to another group, and Nazi Germany is the example where 10 times more people died as a result of a group of people trying to feel superior than COVID-19 killed so far. You know, 10 times more. So if we were to somehow be more humble, less arrogant, less alpha male dominated kind of culture, but instead cooperate, which I should say should be the message of science. Science is based on cooperation, and people should support the acquiring knowledge. But even within, you see what happens when you try to argue that, you know, maybe we missed something about reality. Then people like Galileo try to argue that, and they put him in house arrest. And even nowadays, it's quite disturbing to see how reluctant are some groups of scientists to engage in learning about reality. Instead, a lot of people would prefer to just show that they are smart and, you know, ask how many angels can sit on the tip of a pin, even though such a thing doesn't exist.
Coming from a theoretical physicist, I love the fact that you
Right.
you're very willing to smash down on people who spend so much time in thought experiments as opposed to discovering reality. Yeah.
I was fascinated by philosophy to start with, but I do think that our real teacher is nature. You know, it's not other people. Other people have their own reasons to believe in virtual realities that flatter their ego. They would rather be at the center of the universe, and they would rather put a goggle. If the real universe is not one in which they are at the center, they would put goggles on their head that allow them to think that they are at the center, or they would be in a group of people that believes in the same false narrative. And all of these traits are not the traits of a modest being, and if you're modest, you just try to learn like a kid. That's why I always say that if we were all behaving like kids, the world would have been much better. And when I look at an adult nowadays, I always try to uncover the kid in that adult. That's why I don't take anyone seriously.
Well, and that's why you come on our show all the time. Thank you for that. That being said, I have a question for you regarding this very thing, because I was listening to Brian Keating the other day, and he was talking about theoretical physicists. And one of the challenges, or one of the frustrations he has with theoretical physicists, is that they're very unwilling to read the work of other theoretical physicists as they develop their theories of everything. Why do you think that is? And is this a huge problem in academia or the scientific community currently?
Right. So the issue is really that in theoretical physics, since the mid 1980s, there was a stagnation. There wasn't much feedback from experiments. In fundamental physics, there was the Large Hadron Collider that was supposed to be funded, but the funding was stopped in Congress at the time in the mid 1980s. And as a result, there were decades of no feedback from experiments, in fundamental physics. Broadly speaking, I mean, of course, there were some small experiments that provided some new insights, but globally, there was no big collider that was funded until the Large Hadron Collider came along decades later. So it was not in the US, by the way, so it was a European endeavor, so the US lost its prominence. But that also led to a culture of theoretical physicists that work on quote-unquote fundamental physics without any feedback from experiments. Now you ask yourself, okay, what does it remind you of? If you have a community of people that have no external way of measuring the validity of their ideas, it reminds you of philosophy, humanities. It reminds you of
religion,
theology. So under these circumstances, there is no way to vet how much more successful one person is relative to the other, except if they show that they are smarter by doing mathematical gymnastics, by being in a big enough group that dominates socially the field. And so what you find is a dominant paradigm, string theory, and any competing ideas are being ridiculed. There may be some reasons why those ideas are less appealing, but it has nothing to do with experimentation. So it's not as if string theory has support from any data that it is the correct path to unify quantum mechanics and gravity. We don't know that because there are many string theories that are possible, and they make no predictions on the crucial issues of the day, like what happened around the Big Bang, or what happens at the singularity of a black hole. When I asked one of those string theories to tell me what they predict, they say, well, it's too complicated. So my point is, if you bring a plumber home and you ask the plumber to fix, the toilet, and the plumber says it's too complicated, you don't call him a plumber.
You don't pay him.
The point is, until they fix those issues of singularities like the Big Bang, what happens inside a black hole, I have no confidence that we are going the right path. And under these circumstances, you should not ridicule other approaches because you did not establish a foundation to your approach that is rooted in data. That's my whole point. So you should be modest rather than arrogant and say you are leading forward the torch of physics. And there are lots of people that try to publicize this message. And I will not mention names, but they get a lot of airtime. And they are socially accepted by the scientific community because they promote this narrative that has no foundation in any experimental data. And the question I ask myself is, how come this is not a speculation? And considering the possibility that there are others like us on so many planets that have conditions similar to Earth that may have produced some equipment that we might find in space, that is considered outside of the mainstream ridicule, whereas talking about extra dimensions, the multiverse, things that we have no way of telling whether they are real or not. That's mainstream. That, to me, is a real puzzle. And the only way I can explain it is because this culture grew to become sufficiently strong and big for so many years that it doesn't even recognize that it has this flaw. It has a blind spot. It doesn't even recognize the need to apologize for not having contact with data.
Well, and this all started in, if you look back at the early popularizers of science, like it was in the 60s that people that the average everyday person actually started to become interested in a lot of these bigger questions in science, or were actually able to understand, because there were media popularizers who were beginning to have conversations with the public about these things. And I think the problem is it's very difficult for the public to be able to understand what's popular versus what's experimental and what's valid.
So what I would argue is that it's the duty of the academic culture, the people in academia, to listen to the public, to the kind of questions that are of interest to the public, and address those rather than argue. Let's show that we are smart so that we can give each other honors and awards on the question of how many angels can sit on the tip of a pin, because we define this question to be intellectually stimulating. Who cares whether the public understands it or not? It's just a sandbox in which we can demonstrate that we are smart. Okay, that's pretty much the culture. Let's build a sandbox where we can demonstrate that we are smart. My point is the goal should be different. The goal should be, let's listen to the public and see what they are interested in. So if they care about finding a vaccine to COVID-19, then obviously we should develop an mRNA vaccine. That's obviously recognized by the appropriate community. If the public cares about whether we are alone in the universe, whether there are, what's the nature of unidentified aerial phenomena. And by the way, it's not just the public, it's the government that tells Congress, we don't understand what it is. How can the scientists ignore it and ridicule it? How can that be outside the mainstream when the ideas that I was talking about before that have no bearing on reality because we haven't tested them are celebrated? And to me, that shows a problem in academia. And the way to fix it is, of course, one way to fix it is to get a megapixel image of an object that was not manufactured on Earth. Because once we see that image, it will be transformative. And then you might even get $1 trillion a year for science. And what I was telling my colleagues all along is, we can bring new funds to science. We can bring new talent to science. We can make science exciting if we only address the questions that the public cares about. And they say, and they attack me on that. They say, no, you are emphasizing a niche that is too speculative and so forth. I cannot really understand why that is not happening, but I know the path to making that transformation, and that is to find a high resolution image. And by the way, if you were to ask Marie Antoinette during the French Revolution whether she embraces the principles of the French Revolution, she would say no, obviously, because she benefited from the old system. So if you ask people that benefit from the current system in academia to change their frame of thinking, that they will obviously resist that, because they flourish in this set.
But Avi, you flourish in you're an incredible scientist. You're an incredible astrophysicist. You're a theoretical physicist as well. You're an astrophysicist. You're flourishing right now, yet you're calling people out for this very thing. How can you flourish calling this exact thing out while these people think they can't? Why is that?
Well, okay, so I will be 60 years old in a month. Okay,
and you don't give a
no. So let me explain. I wrote an essay, published it on Medium, that is called "Life Lessons After 60 Years," which is basically what I learned in 60 years. And I should say there are only 3 lessons, so it will not be very long. And moreover, I didn't really obey these lessons early on, so I was not smart enough throughout most of the 60 years. So let me give you the tip so that you can avoid the mistakes that I made. So the first mistake I made, and by the way, this relates to your question about other people and so forth. The first lesson that I learned, I mean, and this all came about, my understanding of those lessons came about when my parents, both my parents passed away a few years ago, and I realized how precious our life is. So the first lesson is focus on the time that you have remaining to enjoy, rather than on the past accomplishments. So, in the past, I used to always think about what I accomplished. It's sort of like wearing medals that you got in a competition, and then being proud of that, and that makes you lazy, sort of being proud of yourself, also arrogant. And instead, you have a short amount of time left in your life. So what's the point about thinking on the past? That makes very little sense. Let's make the best out of the time remaining. And that will keep us modest also, because we would recognize that we have a short amount of time. After this time is gone, who will remember the medals that you received? Nobody would care about it. It's completely irrelevant. So instead of focusing on past accomplishments and being addicted to getting more accomplishments under your belt, just focus on how to enjoy the time that is remaining. And then the second lesson is start every day from scratch, without prejudice, without being entrenched in views that you had before, without any arrogance, not thinking that you are superior relative to others, and without any sense of privilege. Because whenever we thought that we were privileged, we were proven wrong. We thought that we are at the center of the world. We thought that the Earth-Sun system is special. No, half of the sun-like stars have a planet like the Earth, roughly at the same separation. So, everything you find around you should not give you a sense of privilege. And then the last lesson is that, money is only helpful in buying freedom. So up to a certain point. When I was young, I had to worry about getting enough money to get food, get the clothing I need, pay the rent. But once you get to a certain phase in your life where you have enough money to satisfy your basic needs, I don't think that it serves any good. You don't need more, because if you get more money, it brings more concerns, more worries about how to keep it, how to maintain it, how to get more. And in fact, the most precious thing in life is being free, not needing to worry about things. So not worrying about things, meaning you have enough money to buy clothing and food. And, I pretty much eat the same thing every day. And having that minimum, if I get more money, it will go to my daughters. I don't really need it. And then I don't have to worry about trying to get more. So when I put my essays in, for example, in Medium, I selected not to get anything out of it. I could have tried to make money out of it. I say, no, I don't. I'm not. What will I do with that? So the point, I want people to sort of see my essays without having a paywall. And so my point is, freedom is really the fundamental commodity that is most precious. And a lot of very wealthy individuals are not happy. Their life are, full of concerns and worries about how to preserve the money they have, how to make, their assets bigger and so forth. And I think it just takes away. It's a distraction. It takes away your freedom. So these are the three lessons.
Right. And so,
well, hold on a second. I'll say this. Well, maybe if you were a little bit better with your money, you'd have an extra 100 million laying around and we can fund this thing.
Yeah, that's an excellent point. I thought about that. If I was then I could fund the project. That's a good point. Yes.
Somebody had a killer question about when you have do you have a time frame as far as when this camera system is going to be up and running? And then maybe to further that question, when do we expect to maybe start seeing some data from it?
Right. So we will start putting it together in April, and hopefully we will be done through the summer. It will work. It's always possible something will not work the way we hoped, but if everything goes as expected, then by the end of the summer we'll have it working, and then we will make copies of it after that.
There you go. There's your timeline. Start putting it together in April, and then having it online hopefully by the end of
August,
summer.
September sometime.
Yeah,
late summer.
Yeah, by the end of August, hopefully. But the point is, this will be our first fishing net, and then we need to make more of it.
Right.
Well, and Avi, do you have some desired locations for the next iterations?
We are talking about it, and we haven't decided yet. There are places. So the one interesting thing about the reports, if you take all the reports about UAP, they're very, I mean, the density of reports or the rate of reports is strongly correlated with the population. So in places that are highly populated, you have more reports. And that includes also military bases because they're looking at the sky all the time. So some people say, "Oh, why is it military bases that are that carry a lot of reporting?" And the reason is obvious because they look at the sky to make sure that there is no adversary out there. And so the way I see it is, the more you look, the more things you find, and then you have to figure out what it means.
Right. So it's almost as if there's a bit of not confirmation bias. Yeah, but it's similar. It's selection bias. Would that be selection bias?
Yeah,
and survivorship a little bit.
But it's probably a mixed bag. Like most of the objects are probably drones or things that you're not aware of. A small fraction might be interesting, but it's sufficient to have one object from an extraterrestrial origin for the entire fishing expedition to be worthwhile. And the point is, it's not obvious to me that you have to go to a ranch in Utah to find something interesting.
Yeah. Avi, you have given us almost an hour and a half of your time. It's been an absolute pleasure. I don't want to keep you. I know we only talked about having you on here for an hour, so we really appreciate your time. If people want to contribute, if they want to support you, what should they be doing?
Go to the Galileo Project website at Harvard University, and there is a button there, a tab that says support us, and just click on that and it will direct you. And it depends on the level of support. If it's above, if it's very significant, then you can just shoot me an email and I'll
the VIP.
Depending on the amount of the donation, you might get a phone number response back.
Yeah.
No. I mean, it really depends on how many zeros you have.
We were talking about, I mean, we had the Big Phone Home event, which was our outreach event to Congress and local and state officials. And now we just had the other day, and two different occasions, Representative Carson from Illinois, who's on, I can't remember which security commission he's on, or subcommittee, excuse me, off the top of my head. But the idea this time around was, hey, how can we galvanize these people that made all these phone calls and wrote all these letters? Can we get in touch with Elon Musk and put him in touch with you?
I would be delighted to communicate with him. I didn't have a chance yet.
Well, just FYI, we'll be doing this through Twitter, so we'll have to figure out a way for him to get in touch with you. But I mean, that's the idea, is to get in touch with him through Twitter and see if
actually I just wrote an essay before I came to speak.
I thought you were about to say I just signed up for a Twitter account. I was about to be
no. I wrote an essay in Medium that mentioned the Starship, this new rocket that is being built by SpaceX. So Elon can check it out, this essay. I compliment SpaceX there, and I'd be delighted to speak with him. Yeah.
Well, I mean, it's going to be something we're going to try and do. We'll see what happens.
Thank you.
Yeah.
Appreciate it.
Avi, what a pleasure. Thank you so much for joining us today. And we will catch you very soon. I thank you again for coming on the show as often as you do. It's truly a pleasure every single time.
It's a pleasure for me as well. Thank you.
Bye-bye. Thank you, Avi. Okay. Bye-bye. He's so great.
Yeah. I'm pretty sure that he just called the current scientific apparatus a circle jerk, though. Which was
a tool. He called them tools.
He was kind enough to say it so that we can pat each other on the back and give each other medals, but he called it a circle jerk.
100%.
I mean, I would love to if I could wave a wand and put him in charge, I would. The only thing that would make me hesitant to do it would be like, well, are the movies going to suck if I do this?
You wouldn't get any Dune. Dune's out.
Yeah, you definitely wouldn't get a Dune or a news, Boba Fett or anything.
We're not putting him in charge of Hollywood.
Oh, I mean, why not? And just I wanted to mention this, but I didn't want to interrupt. So if you guys liked Arrival and you haven't read the short story, it's called Story of Your Life, and it's by Ted Chiang, and it's part of an anthology of short stories. And if you really like Arrival, they're all phenomenal, really good. So a little plug for him.
Oh, what was the name of the book again?
The short story is Story of Your
short story.
Life, and I can't remember the name of the anthology. But Ted Chiang's the author. Shouldn't be hard to find, but they're all comparable. Really awesome stuff.
Brooke's always trying to get me to read.
I'm trying,
Yeah.
man. One day I'll get people reading again. You see all these books behind me, man?
It's so
Dude,
tough.
you read so much. I am horrible at creating the time, prioritizing the time to read. Brent Hornick with a $5 donut. Great show. Thank you so much, Michael. Louise Brooks, thank you again for the honor of asking my question. It was a pleasure, Brent. It was a great question. Yes, this is a new studio, Tim.
It's a new house.
And we're only in phase one. We're only in phase one of the new studio, so it's coming. It's about to get crazy. We missed this one. I feel really bad. John Paul Zagami, 499 Dolo. What do y'all think of the Aerial School, Lonnie Zamora, Rendlesham Forest incident, and the Chill Bolton crop circles? Thank you all for your work. That's a lot of things. That's like 3 things.
All 3 of them are very good. The Aerial School phenomena is probably my favorite out of the 3, just because there were so many witnesses, and the innocence of those witnesses. They were all children. They were all kids. I mean, I feel like kids, of course, can probably make stuff up, but the veracity and sort of earnest honesty in which these kids, I mean, they filmed them. They all have all of their confessions on film. It's crazy.
Yeah.
That's a crazy. I mean, for me, closest thing to a smoking gun is that case.
It is weird. Like I am always interested in psychology and sociology, and I always am curious about the phenomenon of mass hysteria. And I'm not saying that's what it is. Everyone, calm down. I'm not saying it was mass hysteria. I'm just saying it. Right. It is fascinating how trauma can cause, a sort of.
And we've seen so much evidence to show that the human's ability to retain information and episodically regurgitate what they believe they saw can be manipulated so easily. And I mean, not to say that it's impossible to get a true eyewitness account, but our brains re-record everything every time we bring it back up. I mean, the hippocampus brings the information up, it gets restored and copied over. I mean, it's a shit show in there.
Yeah, we're all shit shows. But it doesn't mean it's not true. Like there are so many, like I mean, because like horrible things can happen, they can be real, and you can have groupthink, right? So it's like it's so difficult. It's so difficult and that's why
I do enjoy the randomness of that case, though. It's just like this little rural school in Zimbabwe.
Right. Like that was in the 90s, right? Is that
no, I believe it was in the 80s, if I'm not mistaken, because it was John Mack. If it was the 90s, it was the early 90s. But yeah.
Aaron shared Stories of Your Life and Others. That's what you were talking about, Brooks?
Yeah, that's it. And it's like I said, the whole anthology is worth a read, and the whole thing's like maybe 130 pages, something like that. It's awesome.
I love how you try to convince me to read by telling me how many pages it is.
Well, no, I think he's trying to convince the whole audience to read, Michael.
I'm here to brainwash.
I don't think it's just for you.
I have an agenda. It's a super biased agenda.
People to start reading more.
I do love that a couple people mentioned this in the comments, how like when Avi comes on this platform, like here in UCR, like he tends to open up a lot more. Like you get a real sense of Avi the person.
Yeah.
I
love that
there's a lot of personality there, and that's awesome.
Yeah.
Oh, are you talking about the fact that he stopped trying to make money and he's like, oh.
I think our conversations always bring out fun tidbits because we have fun with him, because he is very much of the mind
he's
of
a kid like us. He's just smart.
Seriously,
he's just because he's smarter than us doesn't mean he's not a kid like us. And I think that's what's so cool about Avi is like he does not shy away from sharing in that like those joyful moments. And we were talking about
his opinion on Star Trek, like I was sitting there in my brain, I was just laughing like 12-year-old Avi Loeb at school being like, yeah, no, Star Trek sucks.
Stupid.
It's stupid. And all the kids in school are like,
What? Come
you
on.
suck.
Yeah, but then he pulls out a whiteboard and just does the calculations for him, and it's like, see, you guys are dumb. Get out of here. You know, so it's
no. I think they just screamed nerd and maybe beat him up. I mean,
Oh,
like that's
I've been there.
crazy.
he wrote
That's
a whole.
crazy.
He had a he wrote an article. Let me see if I can find it here
so funny.
about. He was talking about the metaverse.
With the
Oh,
NFT monkey. Yeah, it's a great article.
Yes, and he got interviewed by it was an NFT monkey. And he shows up to this interview and he's like frustrated and irritated that this guy, but the guy was like, no, my NFT, this skin is worth tens of thousands of dollars.
And he basically goes,
He's like,
shit, I want to see your face. And so he brings, and this was, and I wanted to ask this question, but we didn't have another 45 minutes because it would have generated that. So in that article, he mentions that he loves, and he actually said this today when he was talking about jogging, that he loves the adversity that reality creates, you know, nature and what it's done and all of its, you know, evolutionary majesty. And then goes on to say, but if we're going to go populate foreign planets, we don't let nature do it because nature's not going to do what we want it to. So we need to go make AI, sentient astronauts to colonize planets.
right.
Oh my God. Like that's a 4-hour conversation. We're not going to be able to have that one. But he did not give a crap about that guy's NFT monkey.
Well, what I loved is at that conference that he went to with Avril Haines and Jeff Bezos in Washington, D.C. at that cathedral, he straight up was like, yeah, I think it's stupid to send humans in this space. Like, we're not made for space. We're not made to you know, like evolutionarily advance in space. It's so dangerous. Why wouldn't we send robots? You know, I was just like, yes, that makes perfect sense. But it does bum me out when he's like giggling, laughing, just how stupid the idea of getting on a spaceship and going to another planet, you know, and like having like a captain and like a starship. He's like, that is stupid. I was just like, wait a second, but what?
You're crushing our dreams. But you know, he's not wrong. And give it another 1,000 years if we survive that long, and maybe things will change.
I mean, I can't look, if humanity makes it 1,000,000 years, we're
going to be stuck in the metaverse.
I can see us definitely sending drones way out into deep space, but I just can't not imagine. Like, I think of The Fifth Element where they've got like a cruise ship that goes to like a local planet, you know, like I cannot imagine we're not going to have stuff like that.
I am kind of sad that obviously.
Yeah, in the local, right. We'll have that in the local. Yeah. Right, like the ability.
You don't think we'll be trying to go to other star systems and meet actually face to face other intelligences? Or
I mean, it depends on if Chris Plain could get his warp bubble story straight.
You've got to be in space. I mean, come on,
that was. Hey,
yes.
No, Plain was supposed to join us today, and he was like, he got mixed up in the last few minutes. So you know, he's like, I'm sorry, I can't come on today. But it was just any opportunity to give Chris Plain some shit, I'm gonna take it because I love him. He's my buddy.
I thought that was a pretty funny line there. I mean, but to be real, if he did get his story straight on this war bubble, I mean, we might actually have an answer for it. But shit, I mean,
there he is. He's listening.
I can just imagine the pit in his stomach. He's like, God, I thought I put this behind me.
Oh, man. Dear.
Funny.
We love you, Chris.
We do love you. I mean, dude, did you? By the way, Christopher Mellon wrote an article for the Debrief today. Chrissy Newton's having an interview with Chris Mellon. I believe it premieres.
today, I thought.
Today or tomorrow?
Or maybe she recorded it today and it goes live
I know it's definitely
tomorrow.
pre-recorded. And then Ryan Sprague dropped a big hint that he's going to be having, you're going to want to be, on your couch watching YouTube at, early tomorrow morning. So who knows? Maybe we get a trifecta of Chris Mellon from the debrief.
Yeah, there's I know Chris read, I think, because Mellon had his 4,000 word article come out. That was today, right?
Yeah.
Okay. Did you get a chance to get on that yet?
Yeah, I read it already.
Oh, you did?
Yeah.
And anything?
Chris said that I think the video from Chrissy's up now. I think that's what he's referring to. Yeah, I mean, basically he's...
Oh, yeah, go check that out at the debrief. After this show, go over to the debrief and check out Chrissy's interview with Chris Mellon.
Yeah, I think it basically, what Christopher Mellon was laying out is that, since especially from 2001 to present day, we've had so many different instruments, both in space and terrestrial, and different ways to report all of these anomalous objects that have been tracked and caught by these systems.
Right.
And the fact that they haven't been whittled down and put in front of the right people on a consistent level is insanely frustrating.
Right.
Especially coming from these military protection services, essentially. You know, like they're supposed to be looking at this seriously, and because it's got this stigma attached to it, they're kind of just literally brushing it under the rug. And it's like, why are you doing this? The thing that kind of confused me about it, though, is I don't understand, because from a public's point of view, I think what the public needs most on this topic is clarity. And I don't think information from the time frame that he wants it collected from, which is 2001 to present, I don't think any of that data, it's going to be a very difficult time getting that data surface to the public. And by the time it does surface to the public, it'll be so redacted, I'm not sure how useful it will be to clarifying the conversation. I'm really, 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 really confused as to why they do not focus on the older systems that are not classified, that have collected data as well, that is just as valuable, that doesn't give away sources, methods, or new
right, because it's
technology.
Because it's not being used anymore. Right.
I just don't understand. This is the part that I think is starting to become the most frustrating for me. Why are we not focused on the stuff that should already be unclassified? Part of me, of course, wants new stuff too. That would be great, but I just feel like it's a harder road. Why are we going to go that route when a lot of these systems that Mellon mentioned are older systems that can be also used from cases that happened pre-2001.
Right. No,
so, it was a great article.
And maybe Chrissy, who's in the room right here, maybe she asked him about that in her interview over the debrief. So don't forget to check that out. I just wanted to real quick. Okay, so this is Avi Loeb's article about the metaverse. He said, when I opened the link to my first interview in the metaverse, the interviewer appeared to be a monkey with a heart-shaped glasses. He introduced himself as the avatar of the real interviewer, Club Metaverse podcast host Mark Fernandez, whose voice I could hear. Fernandez reasoned that this monkey is a Fernandez reasoned that this monkey is a non-fungible token worth tens of thousands of dollars because it was part of a rare digital collection. During the Q&A, I explained to the metaverse monkey with heart glasses that as a scientist, I am in love with the actual reality of the physical world shared by all humans. As a result of being in love with the physical reality, I want to know everything about it and not be distracted by fictitious notions of it. Just like cosmetic makeup, these notions hide true beauty along with any pimples. Naturally, I prefer to see my real interviewer's face and not the avatar. Even if the latter, digital art is worth a lot of money. The dude pulls no punches, I swear. Like, I really, really respect him. By the way, did you guys see this today? Hold on. This is, speaking of the metaverse.
Oof. Yeah.
Oof.
Oh.
Meta Platforms, formerly known as
that's Facebook, because of the privacy clause and from Apple's iOS just made them shit the bed on all
Well,
their...
but this has been months in the making. I'm a
Oh, yeah.
Facebook marketer. I deal with this every day. We've been dealing with iOS 14 forever, but
It was
today
the
at
earnings call.
yes, it was the earnings call where they were like, we're not making as much money as we thought, and Facebook and Meta being a growth stock just plummeted 24.
26%?
The biggest, I believe, I could be wrong here, but I believe this is the biggest single stock loss in
That's correct. $190 billion in valuation gone in a day.
In a day.
You know,
between
you, I swear to God, you want to know the
4
first thought of
o'clock
my brain?
Between 4 o'clock
Yay.
and 5:30. What?
First
Yeah,
thought of
5
my
o'clock.
brain.
Huh.
Aww.
Poor Zucky. Yeah,
sad.
but you know what? One of the
Thank
interesting
you.
things.
So
One of the
sad.
interesting things from the earning call was that that the Oculus is doing well. Is that their virtual reality ventures is still doing well. So
I think that I think they'll. Yeah, I if you are a buy the dip investor, I don't think it's a bad idea.
well, I don't know that one's going to come back real quick.
Oh, it's
I
not
think
gonna
it
come
might.
back quick.
You
It'll
can't
come
bet
back.
against it.
Man, have you seen the
It'll come back.
subculture that is kind of growing around virtual reality replays, like things that are going down in virtual reality that are being recorded and
Oh.
uploaded as on like TikTok stuff?
I'll bet.
First of all, it is the absolute Wild West, man.
It
is. They're gonna have a hard time policing this for the first year or two, because I mean, every
It's the
maniac
Wild West.
has immediately bought these goggles and is like, "This is Westworld, and I'm gonna roam through this as such." And they are just maniacs, man.
But look at this one. Look at Wired magazine coming out swinging.
I loved this article. Yeah,
Big tech needs to stop trying to make their metaverse happen.
Yeah, the reason that I sent this to
We
you,
don't
Mike,
want
was
it.
because
Yeah.
they,
What do you got? Break it down.
No, basically, the whole idea behind the metaverse. So you go back to the book Snow Crash. I know I'm plugging reading again. Sorry, but you go back to the book Snow Crash, which kind of formulated the idea of the metaverse. The idea was that Earth is, almost uninhabitable. Life sucks, so people plug in to go live. And it's a platform that's created by the users so that they can escape reality, not something that the corporate overlords have, jammed down their throats, which is kind of the formulation we're seeing happen here.
So you're saying, and this is kind of Avi's point too, right? Like it's not that bad out there. Just because it's cold doesn't mean you can't run. And
right.
Speaking of which, he was talking to me because I live in Florida, and it's been in
20.
like. It's been in the what? It got down to like 30 the other day.
It was 29. It was 29. I like to tell people it was in the 20s. I mean,
and I flat out refuse to do like, I've been trying to get out, go run in the morning, like get my workout. Like I flat out was like, nope, I'm just gonna have a couple cocktails in the evening and sleep in because it's too cold. So Avi is way harder than I am.
He's got that Boston blood, man.
Avi is hard. I'm weak.
But yeah, I mean, and that's kind of the point of this article is the instances that predicated the invention of the metaverse were nuclear holocaust or severe climate change, and so man had to find a way to live even though our environment was terrible. In reality, if you go outside, I mean, 29 in Florida is not ideal, but it's not nuclear winter either.
Right.
So I don't know that I need fungible monkey tokens.
Exactly. So 1992 dystopian sci-fi novel Snow Crash, where the metaverse is the virtual refuge from an anarchy-laden world controlled by the mafia, and was brought back by a series of blog posts by VC. And this is what cracks me up, is the amount of people out there who are so invested in their conspiracies. And don't get me wrong, rich people, the 1% can be assholes and they can cock block a lot of shit, right? They are very selfish. But to think that they're like there's just the mad scientist intelligence that people believe these global elite cabals have, that's where that's where I find it to be a bit amusing. Is anybody hungry? Because I can't not get rid of this thing.
Are you trying to feed us your cat, Michael?
I mean, somebody, please.
Christopher Plain is jumping all over me because I didn't have a prepared book report for the 8,000-word essay that Christopher Mellon dropped.
I was the one who zanged him, and now he's attacking you?
Yes. That was what my first takeaway from the article was these systems. You know, he wants it to get to Congress in from this time period, but plain to say, Mellon's post focuses on the fact that all 144 cases from the UAPTF report came from the Navy, and the United States Air Force provided no data, even though Congress ordered them
Well,
to.
we've kind of seen this culture shift from the Navy, right? That they're going to be willing to address this, but we haven't seen something collaborative from the Air Force. Correct me if I'm wrong, but that's kind of the gist I've gotten.
Yeah, I mean that's well. I mean, he also says, I could come on the show tomorrow to explain if necessary. It was almost 8,000-word feature, which is a bit much for Luis. This is coming from the guy who got the war bubble wrong. Let's see here. What else did he say here, Mr. Plain? Mr. Plain. According to Mellon, the United States Air Force has the best data collection systems, but doesn't think they need to do what Congress tells them, which is also true. I mean, the United States Air Force has been super quiet on this basically since Project Blue Book. I mean, that's like this is the final word, and we pretty much have no opinions past that. And I think they also had in the 90s they released that Roswell final conclusion or final verdict report. Right. And then that was, I believe, one of the last things that they really were like, this is it. We're not talking about this anymore. And yeah, Christopher Mellon is pointing out that, yeah, they've got the best collection systems out there, and they should be a big part of this conversation. And they're just straight up going, nah, we're good.
Well, and that's what Brooks asked that question to Avi earlier. Do you think these departments, these bureaucracies will ever come together and start working together and talking to each other? And the answer Avi said was
no.
Yeah.
Speaking of the opposite of no, which is yes, if anybody's watching this right now and you haven't hit the like button or subscribe or click the bell because you enjoy this content, this kind of conversation, you want to be here next time Avi shows up, just saying, just hit the button.
We didn't even get to Jacques Vallée joining the Galileo. I'd like to.
I didn't even know that.
Yeah, well, that's all right.
You're like, you wouldn't know that if you showed up to any of my shows.
Yeah, if you had fucking watched our show that we both developed, I mean, no big deal. No, it would be cool to get him and Avi on if we can try and swing that.
Oh, I know Avi would come on with Vallée. We just need to get Vallée. That's the biggest challenge. I did talk to him. I spoke with a person. I'm not going to say that person's name, who told me that he actually responds much more to Facebook Messenger. So I actually reached out to him earlier last year, and he said that he'd be happy to come on when he gets back from Brazil. But
I remember that.
Yeah, I don't know.
He's well, let's hit him up now and tell him we're good friends with Avi.
This is how you power broker podcast. Yeah, it's all about.
Just tell him. Yeah, we've been on the porch.
Don't lie to the man.
Oh, I can't tell if this was a burn or not from Rashu. I'd like more consistent content to like. Is that because I haven't shown up in 2 months? Is that
you're missed?
That could be it. I mean, it has been 2 months, Michael.
It's been 29 in Florida. We can't operate, guys.
Christopher Plain's hiding in his war bubble right now. Oh man. Hilarious.
You guys are the best.
So funny.
I truly adore the people who show up for this ridiculousness because they are our people.
Yeah,
that is a fact.
Indeed, it is.
Do we got anything else before we wrap this shindig up?
We've got Bryce Zabel coming on the show tomorrow.
Give me more. Say more.
You don't know who Bryce Zabel is, do you?
Don't. Lou.
It's fine. It's fine, Michael. You don't have to. That's why you're so great to the conversation, because you don't know half these people. Yeah, no, he's a filmmaker, journalist, producer. He does the podcast with Ross Coulthard. Both of them do that podcast. So yeah, just a very interesting guy. Very, very interesting guy. He's been in the field for a good long time. Produced a show on NBC called Dark Skies, which is about, UAPs, UFOs, stuff like that. It was kind of like a wannabe X-Files, I think, but a little bit more grounded, not as fantastical or sci-fi as X-Files.
Right. They maybe dives less into the paranormal aspect, like because X-Files really started to get into the paranormal as well.
Yeah.
As Grant Levine. Oh man, you guys just gave me hours of montage content in today's show.
Well, please save the Bryce Zabel stuff for after the interview. Just do me that favor.
There is no reason to offend an upcoming interview.
Just because Michael doesn't know who he is doesn't mean that everybody else can't enjoy the show.
Okay, a couple things. Make sure you guys join the Discord. The Meat Cutter is in the house, who is like the Meat Cutter and Dasari are like the backbone of the Discord. And also, please don't blame them for everything that happens in the Discord. They're human beings and they don't control the world. Like, can we all just get a grip, please?
I think for the most part,
Good luck.
The Discord's been pretty damn civil.
It's been much more civil lately, and and they've done a phenomenal job.
December or November, really, not even December. Yeah, they do an awesome job. I think the new rules that we've set. I mean, we were, this is all new for us too, man. Like, so we're trudging through these waters literally in real time. So
yes, and it's fun, and there are great people in there, and it's an awesome group. Just don't know that. Remember, it's still the internet, and we're doing our best. Like, just know that.
Yeah, we can't. I'm sorry. Against popular opinion, you can't control what's said on the internet.
We're doing our best.
It's impossible.
We're doing our best. The other thing was I had something. Aaron said it's been very nice lately. Sometimes we had a moderators meeting the other day, and we were like, all right, so we just need to separate these people and just give them their own channels. And we did it, and it helped. That helped. That helped quite a bit.
Yeah.
I feel like there was something else I had. But I don't know. Anywho, y'all.
Do you know who's coming on next week?
Yes, I do.
That could be good info. and play. Take me out to the movies. Take me out to the movies. Take me out to the movies. And get yourself a snack.
It is. God, come on. You had that other thing that you were gonna say, Luis. Remember?
No,
that one thing.
No.
Remember
what?
that thing? The thing you had mentioned earlier that you wanted to make sure you said before the show ended. Next week is David Brin here on the Singularity Lab. We're actually going live at 3 p.m. Eastern because he is on the West Coast. He is an author. Oh, Brooks, if you'd like to come back for that, it is a little earlier in the day, but we'd love to have you. And he's actually a sci-fi writer and a futurist. He's written tons of books. His name is David Brin. And you should check him out because you like to read and stuff.
I do like to read and stuff. I will try to make that work. I would like to. I will let you know tomorrow.
All right.
And besides, like Aaron Brin, the author?
Yes, Aaron Brin, the author, will be here.
Wow.
Yes. He's kind of a big deal. So Hope to see y'all next Thursday for the Singularity Lab. Oh, and also we'll be back up on Spotify and Apple Podcasts. So go check that out. This show will be up pretty soon here in a couple hours. So make sure you check us out there. All right. Fantastic. Well, thank you guys so much for joining us today. It's been an absolute pleasure. Brooks and Luis, my boys, my brothers, amazing to have you and spend time with you today. And all of you who showed up and supported Avi and supported the show, we thank you. Make sure you subscribe, click the bell, and meet us on UCR, the Unidentified Celebrity Review, tomorrow at 4 p.m. Eastern Standard Time, 1 p.m. Pacific. And we'll see you then.
Bye, guys. Take care.
Peace.
Do you want to know about the future? I do, and I know you do too. That's why we do what we do, right here at the Singularity Lab, just for you. Do you want to know about stories about breaking technology? Science? Look right here, I'm looking at my sheet. Marty did it, why can't you? Remember, this is a public access channel. We rely on your donations, so just hit the Patreon. So we can continue to bring you updated science and technology, breaking news every single day.